those last several examples were very heavy on the algebra. And if you had taken calculus maybe a generation and a half or 2 generations ago, it would have been very heavy all semester on the algebra. And what studies found, and what the National Science Foundation in the US tried to remedy, was that even though people could do all the algebra quite well, often they were just manipulating the things formally without having any real idea about what anything meant. So after that came this National Science Foundation grant at what is called reform calculus. And reform calculus aimed to look at everything from 4 different viewpoints, not just the algebraic, but also graphical, numerical, and verbal, meaning like in word problems. So here we have some examples where we don't have any formulas at all. We're going to try to understand what we can say about different things about f and f prime just from the graph of f here. And this is the entire domain of f. There's nothing happening to the left of a. There's nothing happening to the right of I. And if it helps you to imagine a sort of real-world situation, imagine that this f of x gives the temperature as a function of time on some day. So we'd like to ask a bunch of different questions here. We'd like to answer them, actually, in addition to asking them. Starting with f greatest. So where is f greatest? We've got a graph of f here. If f were the temperature, it just means where was the temperature highest? You just go along, look for the highest point on the graph, and down there, it's at letter G. The reason that I skipped the letter f down here, just by the way, is that it can be a little confusing to have the letter f as an x value and as the name of the function. Otherwise, no reason other than that. What value is x least? In other words, where was the temperature the lowest during this day? And that would be at time c, when we were at the lowest y value. And at what x value, if any, was the temperature 0? So was there ever a place where the y value of this graph was 0? No. The y values here are always positive, right? We're always above the x-axis. So the answer to that is none. Nope, never happened. Now we're going to start talking about f prime. And what we need to remember is that f prime is the slope of f. So saying f prime is greatest says, imagine drawing a little tangent line at each slope along the way, at each one of these points along the way. Where would you get the greatest, meaning the most positive slope? So we've got a few different positive slopes. We've got one right here, and we've got one right here. And I hope you would agree that this is a much more positive slope than this one. So our answer for f prime greatest would be E. F prime least, I see sometimes people choose the places where f prime is 0. So they might answer this question and they say at C and at G. But are there any numbers that are less than 0? Sure, all the negative numbers are less than 0. So if you can find any negative slope on the graph of f, that will be lower than a slope of 0. And you can see we've got a bunch of different negative slopes, right? We've got a negative slope here at A, a negative slope at B, and a negative slope at H, and a negative slope at I. And if you try to draw a tangent line at every one of them, I hope you would find that the one right here at H, I'm not very good at drawing tangent lines in this one, at H is the most negative slope, right? So this might be a slope of, say, -6. This is a slope of, say, -2. So we have a tangent line that is most negative slope at H. And finally, where is f prime 0? That's the one we discussed already. That's looking for where you've got a horizontal slope, horizontal tangent line, so C and G. And then where is f increasing most rapidly? That's like if you were walking along this, if this were a mountain you were climbing, where are you climbing up most steeply? So you're not climbing steeply at all. Now you're climbing more and more steeply, more and more steeply. Right here is where you're climbing the steepest ever. So that is at E. And you'll notice that the same question, the answer to this, f increasing most rapidly, was the same as where f prime was greatest. That's where we have the most positive slope. Similarly, f is decreasing most rapidly. Where are you going downward most rapidly? That should be over here at H. And again, no coincidence that we are decreasing most rapidly on f at the same place when f prime is least. So this was a graph of f. Now, let's do something more interesting. I've drawn exactly the same shape, or at least tried to. You should imagine this is the same shape as what we had over there. But now this graph is called G prime. It has nothing to do with that graph over there. This is the rate of change of g. So this is telling me the slope of g at any given point. And again, we're showing you the entire domain of g prime. So if it helps you to imagine a real-world situation, imagine this is, say, the rate of change of a population. How is the population growing? So the units up here might be like people per year. And we've got the same questions at the start and then two new ones at the end. This is a graph of g prime. So let's try to answer the easiest questions first. Those would be the questions dealing directly with g prime. So where is g prime greatest? I've got a graph of g prime. Do I want to look at the slope of this graph if I want to talk about g prime? We don't, because this is already g prime. If you start looking at the slope of this graph, you're looking at g prime prime, or g double prime, which is something that we're going to talk about next week. If we're just saying where is g prime greatest, that means where is this graph at its highest y value, and that is at point F. I've changed the letters here so that now we have an F instead of a G because we didn't want a G on the x-axis and the name of the graph being g prime. Where is g prime least? That's the lowest point down here at C. And where is g prime 0? Is this graph of g prime, remember, not the slope of this graph, where is this graph itself ever 0? Never, right? Because my y values are always positive. And it's important to remember, we're talking about the y values, not the x values. Answering a question like, where is the x value 0, or where is the x value least, those aren't interesting questions, right? The x value is 0 at 0. The x value is least over here. The x value is biggest over here. Nobody really is interested in those questions. This is saying, where is the y value 0, and that never happened. So if you wanted to think about this again in terms of the rate of change of the population, g prime greatest, say that up here, maybe that number was, I don't know, 400. That means the population is growing at a rate of 400 people per year at that time, whereas down here, maybe the rate is, say, 30. That means the population is growing at a rate of, say, 30 people per year at that time. So let's ask the other g prime questions here. Where is g prime increasing most rapidly? Again, we've got a graph of g prime, so we're just trying to see where is this graph on the board going upward most rapidly, and that should be at point E. G prime decreasing most rapidly. We've got a graph of g prime. Where is this graph on the board going downward most rapidly? That should be at point H. All right. Let's move on to the ones about G. Where is G increasing most rapidly? So if you think about this as being, if you had a graph of G, you would want to look for where the slope of G was most positive. But G prime is the slope of G, right? So if we can translate this question as G increasing most rapidly as being where is the slope of G most positive, that's just the same as saying where is G prime most positive. And that's at this high point at F. I know some of you were tempted to say this point right here. So let's look there. If this y value is 400, this y value might be what? 220? So what does that tell us? That tells us that at time E, the population is increasing at 220 people per year. At time F, the population is increasing at how many people per year? 400 people per year. Faster. In other words, if you draw the graph of G, at time E, the slope of the graph of G would be 220, but at time F, the slope of the graph of G would be 400. Steeper upward slope at time F. G decreasing most rapidly. Well, G should be decreasing when G has what kind of slope? When G has a negative slope, right? But is G prime, which is the slope of G, ever negative? Is this graph ever have a negative y value? No. Right? This graph of G prime never falls underneath the x-axis. So G prime is never negative. That means the slope of G is never negative, meaning G is never going down. So G decreasing most rapidly, none. There is no time when that happens. So it's important to distinguish between, and we'll talk more about this next time, the words decreasing and the word negative. Similarly, the word increasing and the word positive. To say that G is decreasing means that g is going downward, meaning that g prime would have to be below the x-axis, and that never happens. Let's do these last three. Where is g greatest? This is our clue for that. The fact that g is never decreasing means g is always doing what? G is always increasing. So g starts somewhere, and then g just increases the whole time. Because the population that we were talking about here is never decreasing. We never have a negative slope of g. So if g is always increasing, where will g reach its greatest height? If a population starts at some time and always increases, when does it get to the highest population? It must be at the end. So the answer for when g is greatest has to be at time I. Because the graph of g, which we don't see, we have to imagine it, right? The graph of g is always going up because its slope is always positive. Similarly, where is g least? That must have been at the starting time a, because the graph of g, as we just said, was always going upward. So it started at some low point, g did, and then it just went upward and upward until the end. Finally, where is g is 0? Now, I said imagine that g is a population, but suppose that we don't know that. We can't have a population that's, say, negative. Suppose that we just have some graph of g. All that we know is the graph of g is going upward the whole time, right? Do we know whether the graph of g is above the axis, below the axis, crossing through the axis? We really have no idea, right? I can try to sketch a graph of g. It might look something like this, going up really steeply and like that. In that case, g was never 0. But it would have been equally possible for g to start down here and come up something like this, and then g was 0 somewhere. But we don't know. We don't have enough information. All we know is the rate of change. So this we cannot determine. If all you know is the rate of change, you don't necessarily know any particular value about the original population. For example, if you say, I'm going to drive 50 miles an hour for the next 3 hours, where will I be? You don't know where you'll be. You'll be 150 miles away from where you started, but you don't know where you will actually be because all you have is the rate of change. We don't know whether this graph is above the axis, below the axis, crossing through the axis. We have no idea when we're trying to think about what the graph of g does. All that g prime tells us is about the shape of the graph of g.